quality control in manufacturing using SPC. Introduction. Quality control is important to manufacturing because it ensures products exceed a predetermined standard set by the manufacturer. A manufacturer wants to ensure these standards, either for economic or legal reasons. Each standard given by a manufacturer has a given interval of acceptable values where variations are allowed to happen. To ensure that these variations are minimal, we manufacturers use statistics to ensure that these products are fitting within these variations. Now, what is SPC? SPC is statistical process control. These are methods that are usually used in the manufacturing process in other industries to help improve certain processes. It relies on statistical tools and data analysis that to observe process performance. XPC also helps detect variations early on, saving a lot of costs to manufacturers. By taking the correct actions, SPC can ensure processes can remain stable and reliable, detecting any defects associated with a product, either this being cost or anything within those variations. In this presentation, we're going to go over some of these tools that SPC use.
Okay, so the first one that SBC will use is control charts, which just keep an eye on like behaviors during a process and look for variations so that if the variation is something that needs to be stopped and or changed, it can be noticed immediately and fixed before something actually goes wrong. And then capability analysis, you're just looking at the performance and how it's actually doing. Sampling techniques, and we're going to go more into that in a later slide, but we're going to talk about the two different types of sampling techniques and the pluses and minuses of both. Then hypothesis testing, which is looking at making decisions based off of the data we're given and in deciding how important some of the variations in the data actually are. So control charts. So they're used to look at the process and its stability and how consistent the actual process is. So they give you real-time insights into process behavior and make sure that they're meeting the quality standards and there's not variations happening before it actually finishes the production. So for an example, a manufacturing process where they track the dimensions of a specific product like a nut or a bolt. The measured dimensions are in the chart over time, and then any time the data will exceed the limit, it will create deviation, and then it can mark it, and then you'll know where it happened, and you can fix it as necessary. And now we're going to go on to process capability. So this looks at a process ability to meet the standard and actually keep up performance and not fall behind. And it will account for and it uses indices like CP, CPK, PB, PPK, and these actually do the assessing of the performance and looking for the variation and the target values. And then finally, we have the quality standards assessment, and that uses high index values to indicate compliance with the standards, and then the low values signal adjustments that need to be made to actually get to the right level. And then we have sampling techniques, which is the thing I talked about earlier, where there are two categories. So probability sampling is the first version. It's called random sampling because every single item in the population has an equal opportunity to be chosen in the sample. So say you're looking at a production line with a population of 100 nuts or bolts or something of that nature. Every single nut or bolt in that 100 produced have an equal chance of being chosen. Whereas if it was non-probability, you're using random selection or non-random selection, like volunteering or personal judgment of the sampler to actually look at these things. And the cost of having the probability is that it's a lot more viable, but it's much more expensive to actually do. Whereas the non-probability methods are
not quite as good at figuring that kind of thing out, but they're a lot cheaper. Hypothesis testing is the main thing that we've done a lot in this class. And hypothesis testing will look at two statements about a population, the null hypothesis and the alternate hypothesis, and it will tell which one actually matches with the data itself. And one example that we'll do to figure out whether these two variables are related is the z-test, which needs a population with a null distribution and a null standard deviation. And the z-test is much more useful on larger mass-produced things like we've been talking about. So it's very useful in math production. And then another example is the t-test, which is used on much smaller populations, such as things that need to be much more precise, such as say bearings on a satellite that need to be very, very precise. The t-test would probably be used in that scenario. Then we have ANOVA, which is the analysis of variance, and it'll look at more than two samples and using something called the Tukey procedure. You can tell which sample is working differently, whether or not that sample is what you need in this scenario.
Now, statistical process analysis. Now, in statistical process analysis, we use multiple different methods. These basically are used to do different processes of manufacturing. An example of this is regression analysis. We can use regression analysis to determine errors or unwanted variations inside of our product. A use of variation, we also use it to do like future supply and demand curve. So we can just determine, how much will the business grow? How much processing power will we need in the future? Another simple method of use is ANOVA. We have to use ANOVA to determine significant differences or different independent variables. We can use it to determine a lot of different variances. We can compare a lot of different methods and basically choose the best option out of all these different variables.
And then we have probability distribution, which is yet another thing about SBC. So probability distribution is it's a chart of the different outcomes of a choice and the probability of that outcome actually happening. So the normal distribution is the most common. It is present in a lot of natural types of data. And this is a value where the values are mostly symmetric about the mean, meaning that values are a lot more commonly at the mean than outliers. So they're all going to be clustered more around the center of the graph than out on the edges. And like I said, this is important because it's in a lot of natural data and it's very easy to use to describe a lot of different types of data, and it's really easy to analyze. And a lot of the more useful tests, like I was mentioning earlier, do require this normal distribution. So having something in that nature is very, very helpful.
Now, once we have all this data from all these tests we get, we need to compile all of them. So we have many tools as engineers to gather all this data and then use calculations. Well, some of these statistical software are like Microsoft Excel or RStudio, where we can input large sets of data and we can get graphs, tables, do multiple calculations, and just help us understand what the data means.
Yep. And then finally, we're going to talk about the benefits of the SBC, like we've been talking about all through this. So the main thing is they'll catch deviations early. Meaning you can fix them as needed as you go along, so you don't need to wait until the end of the process when you find out something that's up halfway through. You can stop it in the middle of the process, fix it, and then just get it done. It's much cheaper than manual labor or intensive lab testing, as you only really need a computer and a lot of very easily available calculators like Excel or Studio that we just mentioned. And you can do things, and you can use that deviations very quickly. And because of this lower cost, you can have much higher output, and it'll be of also higher quality due to the reduced deviation. And because of that, you also have a lot higher customer satisfaction, which is something that in any sort of business you always want.
Now, to conclude, we use statistical processes, SAPC, in many ways in manufacturing, because it is an important tool to a manufacturing engineer's career. We use these instruments to pull large pools of data and to test different variations in a product. we use the various products as data, and we then compile this data within our software to get a better idea of what this means. Overall, statistical processes help control production because any poor variation or find different ways that we can improve products as like efficiencies, different cost effectiveness, and overall many variations.
And then
Yeah,
that
yeah.
is our presentation. Thank you very much.
And just do wait, just source file.
There you go.
Yeah.
And that's our sources.